All right, so today we're working on properties of logs, specifically expanding and condensing. Expanding means making it bigger, condensing means making it smaller. All right, so let's do some quick review problems just so we can remind ourselves how to do things. All right, number one, or letter A rather, the log base 19 of 19. Well, remember, we said anytime our base and our y component is the same, our answer is 1. All right, the log base 4 of 1. Remember, we said anytime this number is 1, our answer is 0. So those were a couple of testing to see if you remember the rules problems. All right, simplify the exponents. All right, so let's remember back to our exponent rules. X to the third times x to the fifth. Remember when we were multiplying same bases, we add exponents. So this is the x to the 3 plus 5 power, which is x to the 8th. Ooh, raising a power to a power. Remember, this means that we distribute this exponent to the exponent of every number in parentheses. So this becomes 2 to the 5th times x to the 15th. And let's evaluate. What is 2 to the 5th power? 32. So 32 x to the 15th. All right, E. Remember our quotient rule, which says we take the big number minus the small number, or if you want to think about it this way, we flip this up to the top, and this becomes x to the negative third, and then we combine. Either way you want to think about it, we're going to end up with x squared. Okay, now let's look. Our logarithmic rules. Please pay super duper attention right here. These only work if the bases are the same, the bases. Remember, bases are that little number. The log right here, base what of what? The log base b of y equals x. So these only work if the bases are the same. All right, so multiplication of logs. Anytime you see the log base a of b times c, you can rewrite it, you can expand it as log base a of b plus log base a of c. And this works both ways. All right, so if you see log base a of b plus log base a of c, you can rewrite it as a log base a of bc. The conversion works both ways. All right, so let's look at our examples. Expand as much as possible. So we're going to take this and we're going to split it apart. So one of them is going to be the log base 8 of 3 plus the log base 8 of x. Now let's expand this one. So the log, again, no base, so it's an uninterested 10, so we don't even need to write it. So the log of c plus the log of d. All right, rewrite as a single logarithm. Remember I said that we could go both ways. So now we're going to squish these together. We're going to condense them. So same base, always check that first. So the log of 6x. Look at B. Once again, same base all across. So we can say this is the log of x, y, and we're going to actually put our 5 front. So the log of 5xy, just keep it in the correct order. All right, next, same base. So this is the log of base 4 of 7 times 6. And what is 7 times 6? 42. So we just go ahead and do that multiplication. The log base 4 of 42. All right, rule number 2, the division of logs. And this says that the log, and once again, make sure the same base if you're going backwards. The log base a of b divided by c is equal to the log base a of b minus the log base a of c. We go both ways. Remember, if you're going from this form to that form, to check that your bases are the same. You cannot apply this property if the bases are not the same. All right, so let's expand this as much as possible. So we're going to take it from this form for A, and take it from this form, and we're going to convert it to this form. So we're going to say the log base 9 of 5 minus the log base 9 of x. Next one, example B. The log, we don't have a base, so it's base 10 of 6 minus the log base 10 of 7. All right, everybody following along so far? Take a second, let that process. So multiplication, notice this. When we're multiplying logs, we use addition. When we're dividing logs, we're using subtraction. Okay, so it's very much the same as multiplication and division when we're using exponents. So remember when we had x squared times x squared, we're multiplying things with exponents, we add the exponents. And then when we're dividing, we had x cubed over x squared. Division is subtraction. So this is x cubed minus x squared, which gives me x. Okay, same thing for logs. All right, so now we're going to test our things. Rewrite as a single logarithm. So we're going to say this is subtraction, so multiplication or division. Division. So we're going to say the log, and again, checking for our same basis, of 5. Hang on. I wrote my line too big. So this is the log of 5 divided by 16. Okay, looking at B, subtraction. So we're doing division again. So this is the log of C divided by 8. Next one, oh, we've got 3 parts. Our rules don't change though. Make sure that you're looking at the bases. They are all the same, so we can combine these. So plus, so multiplication first. So this is the log of x, y, then subtraction. So then we're going to divide that, divided by 3. All right, everybody following so far? All right, next, exponents and logs. All right, so let's write this rule down, and so then we can apply it. So if you have a times the log base b of c, we can rewrite this as log base b of c to the a power. And once again, it can go both ways. And this will be really useful later when we're trying to solve for this a value. All right, so expand or condense. So I want to condense this. I want to get this 3 out from in front. I'm going to put it over here. Remember, this is where my exponent goes. So this is actually going to be the log base 6 of x cubed. This one, I'm going to expand this. So this guy comes out front. So this is 4 times the log of b. Ooh, the log of radical 7. But I don't have an exponent. I don't have any. Yeah, okay. How do we write a radical as an exponent? It's to the 1/2 power. So 7 to the 1/2. If I want to expand this, I'm going to take the exponent and put it up here. So 1/2 the log of 7. All right, now let's see what happens if we do multiple steps at the same time. Okay, so we're multiplying. So let's expand these first. Let's take care of the multiplying first. So the log base 10 of x squared plus the log, still base 10, of y to the 5th. Then we can take our exponents and put them out front. So 2 times the log of x plus 5 times the log of y. Once again, this is division, so we're going to expand this. So the log base 3, and this is radical x. I'm going to go ahead and write this with an exponent. The 1/2 minus the log base 3 of 5. Bring the exponents out front. So 1/2 the log base 3 of x minus 5 is the log of 3. All right. Let's look at this next one. C. log base 7 of b cubed times the 4th root of x. All right, well, it's multiplication. So let's first expand it that way. Let's take care of that. So the log base 7 of b cubed plus the log base 7 of x. And if we wanted to write the 4th root as a fraction, we're going to say to the 1/4 power. And then we do the same thing we've been doing. We just pull the exponents out front. So 3 times the log base 7 of b plus 1/4 the log base 7 of x. Everybody getting the hang of it? All right, now let's go back the other way. Let's look at just a couple of these. Let's look at A, and then we're going to look at D. All right, so first, move your exponents back. So the log base 4 of x to the 1/2, and we can actually go ahead and write that as radical x, plus log base 4 of y squared. And then it's addition, so we know it's multiplication. So this is going to be the log base 4. Let me erase that. I tried to write a parenthesis in it. Smart Notebook's not quite keeping up with me. Parentheses. And again, we want to put this in the proper order. So x squared radical x. All right, let's look at D. All right, so first let's take care of our exponents, and then we'll worry about multiplication and division. So this is the log base 2 of j to the 8th minus the log base 2 of k to the 9th plus the log base 2 of m to the 2/3. All right, and if I wanted to write m to the 2/3 as a radical, remember our numerator sticks with this and our denominator becomes the radical. So I would say m squared and cubed root to the cubed root of n squared. All right, now let's rewrite this. So I've got a minus sign right here, so this is division. So this is going to be the log base 2 of j to the 8th over, this is addition, so these two are going to be multiplied together, k to the 9th times the cubed root of m squared. All right, now officially here, we should rationalize this and get rid of this radical on the bottom, but for today, I am not really concerned about that. I want to make sure for today that you know how to put it all together. All right, and so that is it for the day. If you have any questions, be sure to email me or send me a message through Canvas. Have a great day, guys.